In most of the work we do in introductory physics, we talk about ideal thin lenses. In real life, a lot of the lenses are going to be less than thin, and they might have properties that are slightly different than what we experienced in the idealized cases. Most importantly, in practical applications, sometimes we are going to face up to some properties of lenses that deviate from those ideals. In the news, a few years back, when NASA launched Hubble, they had a problem with the original mirror of the Hubble telescope. The problem was based on some mirror aberrations. In that particular case, they were, if I recall correctly, spherical aberrations. Here we talk about lens aberrations, imperfections due to lenses. What we call a spherical aberration is the fact that the lens is too spherical, or the light is coming into the lens far away, far enough from the principal axis so that it will not focus in one point and instead focus on multiple points, like in this picture. And that's what we call spherical aberration. And spherical aberration happens when the lens or mirror is too large, so that the light is coming into it is going to be able to be curved differently based on the ends of the lens. And we don't get that thin lens approximation where all light is coming in close to the principal axis and for a lens that's essentially with no thickness. Okay, so we get spherical aberration from large lenses and lenses with a particular thickness. Another common aberration is what we call chromatic aberration. Chromatic aberration is due to the fact that the index of refraction of light depends on the wavelength of the light. And remember, when we talked about prisms, actually blue light gets bent more than red light. So in chromatic aberrations, we are going to have a smaller focal length for the lens for blue light than for red light. So depending again on what kind of lens we are using, we always have this chromatic aberration, but is it going to be drastic, where it's going to be noticeable, or it's going to be tiny that we don't notice the effect? In prescription glasses, usually they try to correct for that chromatic aberration. Another aberration that can happen is when we shine light off axis on the lens, and where we can get images formed off the principal axis. Okay, you notice here they show the look because we have different focal lengths here, so we actually see several images. This is what we call coma.